This is the last lesson in the course, Lesson 7.2, Hypothesis Testing for Means. In this lesson, we're going to build on Lesson 7.1, where we learned about the hypothesis testing procedure for proportions, and now just talk about how it's different for means. The overall basic procedure is still 4 steps that are the same, whether you're testing for means or proportions. The first 2 steps are still to write the hypotheses and check the conditions, and steps 3 and 4 are still to calculate the statistic, and then finally to make a decision using either the p-value or critical value methods. First, we're going to talk about steps 1 and 2, writing the hypotheses or checking the conditions. And then we're going to talk about steps 3 and 4 over the next 2 sheets. This is because the calculation for the test statistic is different for the mean than for the proportion, and it also uses 2 different distributions, the normal or the t, depending on which information you're given in the question. This is similar to the steps we had to take for calculating confidence intervals for the mean. So before we get to the calculations, let's talk about what the hypotheses look like for the mean and how they're different than for proportions. So first we have the null hypothesis, and the null hypothesis is still the value we believe to be true until we can prove otherwise. For that reason, it should always have the equal sign in the null hypothesis. The alternative hypothesis is the one that we're trying to prove is true, and it will never contain the equal sign. It has to have another sign, like a greater than, less than, or not equal to, depending on the type of the test and the information given in the question. Also, because we're doing the hypothesis test for means now instead of for proportions, the null and alternative when you're doing a hypothesis test for the mean will always be written in terms of the population mean, and the symbol we use to represent the population mean is the Greek symbol for m, which is mu. So this symbol mu is what we'll have in our null and alternative hypothesis for every type of test. Here are all of the 3 options we can have for our hypothesis tests. We can have the right or upper tail test, where the null is that mu is equal to some value given in the question, and the alternative is that you'll be greater than that same value. In the question, look for wording like increase, more than, and the picture will be on the upper or right side of the distribution for the probability. A left or lower tail test, the alternative just moves to being less than the given value in the question. Look for words like decrease or less than in the question, and we'll be dealing with the lower tail probability. And finally, for two tail, you'll have the not equal to symbol in the alternative. The wording usually used in the question is difference or change. And for the two-sided test, you have probability on both sides. This means you're testing technically if you could be less than or greater than a given value. For step 2 on the conditions, we're going to have the same 4 conditions for the central limit theorem than we first learned about the mean case. So independence means that the values must be independent of each other, which means one does not impact another. That condition is usually always true if you have randomization. There are different random sampling methods, and you want the question to say that the sample is random, or if you were collecting data in real life, you need to make sure that you collected it through a random sample. The last 2 conditions are on sample size. The 10% condition makes sure that the sample is no larger than 10% of the population, making sure the sample is not too big. And for the nearly normal condition, you make sure the sample is not too small. It should come from a unimodal and symmetric distribution, which can be checked by making a histogram. In general, we say that as long as the sample size is bigger than 40, this condition should typically hold. Finally, as I mentioned earlier, the test statistic will need to break down into more steps for calculating because the formula varies for the mean depending on what information you're given in the question and the situation. The test statistic will always have the form that you take the statistic minus the parameter and divide by the standard deviation or standard error. But when we're talking about the mean, if you actually know the population standard deviation, the one that we call sigma, our Greek letter S for standard deviation. If you know sigma, then you can use the normal distribution. However, if you only know the sample standard deviation that we call S, then you have to use the t distribution because you're estimating two things, the mean and the standard deviation, which leads to our t distribution. We're going to break down each of these methods individually using the normal distribution and then using the t distribution in the next two worksheets.